The next part of this section will discuss combining signed numbers using subtraction. Again, the only things that we need to know how to do is how to add and subtract whole numbers. Upon completing this presentation, you will be able to understand how to combine signed numbers that are written as a subtraction problem. You will also be able to simplify problems involving both addition and subtraction of signed numbers. Let's start with subtracting integers using a number line. This is going to be similar to our addition problem with one slight difference. What we want to do is we're going to work backwards from what we did with addition. So the first thing that we want to do is plot the first number on the number line using an open circle. When we talk about converting subtraction to addition, think of it as the first number is the result of the addition problem. So this is going to be our closed circle like we did when we did the addition problems. The second thing we want to do is plot the second number on the number line using an open circle. This is one of our original values for our addition problem. And finally, we want to know how many tick marks does it take to get from the open circle to the closed circle. Just like we did when we talked about addition, remember one of the numbers was the open circle that we plotted. The second number was how many tick marks did we move. And so what we're doing when we talk about subtracting integers is I want to know how many tick marks do you have to move in order to get from one of the original numbers to the final answer. So, what are we talking about when we say that? To find a minus b, think of b plus what equals a. So let's go ahead and kind of break down these problems so that we can see exactly what we're going to be doing. So if we go ahead and start with example A. Example A, I have 5 minus 4. And so if I wanted to rewrite this as an addition problem, what this is 4 plus what equals 5. That's how we originally learned subtraction. So if we were to go ahead and graph this, my 4, I want this to be an open circle. My 5, I want to be a closed circle to mimic what we did when we talked about addition. And now I want to know how far do I have to move in order to get from the open circle to the closed circle. This is 1 unit to the right, meaning that this is going to equal a positive 1. Alright, so let's look at example B. Example B, if I were to rewrite this as an addition problem, this is negative 3 plus what equals negative 4. So again, let's go ahead and plot the two numbers that we do have. So negative 3, I'm going to plot it using an open circle. Negative 4, I'm going to plot using a closed circle. And now how do we get from the open circle to the closed circle? We want to move 1 to the left, and so this is going to be negative 1. Okay, let's look at example C. Example C, if I were to rewrite this as an addition problem, this is negative 6 plus what equals 5. So I'm going to plot negative 6 using an open circle, and I'm going to plot positive 5 using a closed circle. And now, how many tick marks do I need to move in order to get from -6 to +5? In order to get from -6 to +5, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so 5 minus -6 is equal to +11. Let's look at a couple more. If we look at -6 minus 4, what this means in terms of addition is 4 plus what equals -6. So we'll start by plotting 4 using an open circle. We will plot -6 using a closed circle. And now how do we get from 4 to -6? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the left. And so this is equal to -10. For example E, to write this as a addition problem, this is 5 plus what equals 2. So if we were to plot these two numbers, we have 5 as an open circle, 2 is a closed circle, and now how do we get from 5 to 2? We need to go 1, 2, 3 units to the left, and so this is equal to -3. Two more examples to look at. Let's look at 4 minus -1. If we were to write this as an addition problem, this is -1 plus what equals 4. So let's go ahead and plot our numbers. We have -1 is an open circle, 4 is a closed circle. To get from -1 to 4, we need to go 1, 2, 3, 4, 5 units to the right, and so 4 minus -1 is equal to +5. For example G, we have -2 minus -7. If we were to write this out as an addition problem, this would be -7 plus what equals -2. So -7 is 7 to the left. We'll use an open circle for that. -2 is 2 to the left. We'll use a closed circle for that. And now to get from -7 to -2, we need to move 1, 2, 3, 4, 5 units to the right. And so it will equal +5. So this is our first method that we can talk about in terms of subtracting integers. So let's move on to another example, another way to look at this.
All right, so let's revisit our idea of subtracting using manipulatives. So the first thing that we're going to do is we are going to put down the number and color of chips indicated by the first number. And from what we know of subtraction, we want to take away the number and color of chips indicated by the second number. Now, one thing to note is if you do not have any or enough of the color you are trying to remove, well, then we need to add them back onto the table. But keep in mind, we can't just willy-nilly add on however many chips we need. We need to counterbalance it. So remember when we talked about adding, we talked about a red and a blue cancel out. So if you have to add a blue, you need to add a red. And add as many as you need of both colors. From there, then you can go ahead and take away the color that you wanted to take away. and what you're left with is your answer. All right, so let's go ahead and look at some examples of this and see what we can do. Okay, example A. We have 5 minus 4. And so what this translates to is I want to start with 5 blue chips and I want to remove 4 blue chips. So I'm going to go ahead and black out 4 of these. These are the ones that I'm removing. And what am I left with? I am left with 1 blue chip, which means that 5 minus 4 is equal to 1. All right, let's look at another one. Let's look at example B. Example B, we want to do -4 minus -3. So we want to start with 4 red chips, and I want to remove 3 red chips. So we're going to black out our 3. And what are we left with? We are left with 1 red chip, which means that this is equal to -1. All right, our next example, we're going to have 5 minus -6. So we have 5 blue chips, and I want to remove 6 red chips, but we don't have 6 red chips. So that's where we are going to go ahead and bring in this diagram over here on the right side. Here I have my 6 red chips, but remember that we want our 6 blue chips to counterbalance that, so that if we look at this combined, we are starting with just a +5. So we'll go ahead and move this over and include it in our problem. And we want to remove our 6 red chips. So if we go ahead and black out 6 red chips, we want to see what are we left with. We are left with our 5 blue chips, and now we have another 6 blue chips, which means that this is equal to 11 blue chips, or just +11. All right, let's look at a couple more. All right, we're going to start with example D. We have -6 minus 4. And what this means is we want to start with -6 and we want to remove 4 blue chips. Again, if we look at just the original figure, this is what we have. We don't have 4 blue chips to take away, so we are going to add in 4 blue chips, and to counterbalance that, we add in 4 red chips. And so now, if we go ahead and remove our 4 blue chips, what are we left with? We have a total of 6 red chips, or sorry, 10 red chips. And so -6 minus 4 is -10. Okay, let's come down to example E. We have 2 minus 5. So I have 2 blue chips, but I want to remove 5 blue chips. And so what that means is I don't have enough. So I'm going to add in 3 blue chips. And again, I need to counterbalance that with 3 red chips, so that ultimately what we have here is 2. We want to go ahead and get rid of 5 blue chips now. And what are we left with? We are left with 3 red chips. And so 2 minus 5 is equal to -3. All right, a couple more. Example F, we have 4 minus -1, which means I want 4 blue chips, and I want to remove 1 red chip. But since I don't have any red chips, I'm going to go ahead and add in my pair, a red and a blue, so that now I do have 1 red. And now we can go ahead and remove a red chip. And what are we left with? We are left with a total of 5 blue chips, which means that this is equal to positive 5. All right, last example, let's look at G. All right, G, we have negative 2 minus negative 7. So this means I want to start with 2 red chips, but I want to remove 7 red chips. So I need to add in enough red chips so that we have a total of 7. I'm going to add in 5 red chips, and again, to counterbalance that, I'm going to have them paired up with 5 blue chips. From here, we can now go ahead and remove 7 red chips, and we are left with 5 blue chips, which means that negative 2 minus negative 7 is equal to positive 5. All right, so that is subtracting integers with manipulatives. Let's look at another example of how you can think of subtraction.
Just like when adding signed numbers, subtraction, we have kind of the same set of rules. We can add the numbers disregarding the signs, like the first 3 here, or we can subtract the numbers disregarding the signs, like the last 4. So let's go ahead and examine these and see what we can do here. For the first set, in order to get from 5 minus negative 6 to 11, what we want to do is change minus negative 6 to a plus 6. 5 plus 6 is equal to 11. For the second set example, negative 6 minus 4, notice that negative 10, negative 6, and negative 4 add to negative 10. So when we see minus 4, we don't want to be thinking of it as subtract. We want to be thinking of it as a negative. For 4 minus negative 1, in order to get to positive 5, well, 4 plus 1 is equal to 5. Here, we're going to change minus a negative to a plus. Let's look at the second set of examples where we are subtracting. 5 minus 4 is equal to 1. Now, this is a very base case example, but when we talk about signed numbers, we want to think of this in terms of signed numbers. What we have here is we have 5 and negative 4 have different signs, so we subtract them, and we keep the sign of the larger number, which was positive. For negative 4 minus negative 3, same thing like we did up at the top. We want to start by changing minus negative 3 into a plus 3. Negative 4 plus 3, we have different signs, and so we are going to subtract and keep the sign of the larger number. For the third example, 2 minus 5 equals negative 3. Again, I want to think of this as being a positive 2 and a negative 5. They have different signs, so we are going to subtract and keep the sign of the larger number, which in this case is the 5. We will keep the negative sign. For the last example, we have negative 2 minus negative 7. Again, I want to change minus negative 7 into a plus 7. Note that we have different signs. We have a negative 2 and a positive 7. We are going to subtract the numbers, giving me 5. We keep the sign of the larger number, which is positive 7. So one thing to note when we talk about adding and subtracting, these are basically the exact same thing. It's just a matter of how we write it. The important thing to remember is when you see a minus sign, when we talk about sign numbers, you do not necessarily want to think of it as always being a subtraction. You need to think of it as being the sign of that answer or that number, and we are going to combine using addition and subtraction. From here on out, I don't want to look at problems in terms, I don't want you guys to look at problems thinking add and subtract. I want you to think combine. Combine means addition and subtraction together, depending on whether your numbers have same signs or different signs. So let's look at the definition of subtraction. Subtraction is the same thing as adding the opposite or adding the additive inverse. A minus B is the same thing as A plus the opposite of B. So our procedure for subtracting sign numbers, we want to change the subtraction operation to addition. We're going to change the sign of the number being subtracted, and then we want to add using the rules for adding numbers with same or different signs as needed. So some things to note when we talk about combining numbers using subtraction. Note, you are not required to change all problems involving subtraction to adding the opposite, but you do need to be thinking it. Remember, a minus sign does not necessarily mean subtract. The only time you need to change to addition is when you are subtracting a negative. Subtracting a negative becomes adding a positive. Remember, we want to change the sign, change the operation to addition, and change the sign of the number being subtracted. So if we change our sign to a positive, we want to also change the sign of the number. Since it was negative, it becomes positive. When looking at two negatives that are adjacent, imagine you can pick up one and rotate it and put it on top of the other to make a plus sign. What do I mean by that? If we have two negatives next to each other, I want to pick this one up and rotate it so that it becomes a plus sign. English majors do not like double negatives. Consider the following statement. I did not misunderstand you. This statement involves two negatives, not being the first one, and miss, part of the understand, is the second one. This is a very pointed way of saying I did understand you. Even in English, two negatives translate to a positive. So let's look at some examples using this rule of subtraction. So, for example A, I want to subtract 7 minus 10. Now, as I said, whether you choose to write it out or not, this is the same thing as 7 plus the opposite of 10, which is negative 10. In order to combine these, note we have different signs, whether you're looking at it from an addition problem or from the original problem. This is 7 and negative 10. So that means that we want to subtract. We get 3, and my larger number is negative. So my final answer will be negative. For example B, we have 5 minus negative 6. The first thing that I want to do is I want to start by changing my minus a negative into a positive. This is one way you can do it. I have two negatives, just play with them and make a plus sign. We get 5 plus 6 equals 11. Now, I had a student who, another way that he did this was you got two signs to play with, you got two lines to play with whenever we are talking adding and subtracting. So I can put lines through both the minus sign and through the negative sign. Either way, we do get 11 for our final answer. Example C. Again, I want to start by getting rid of any minus and negatives. This will become a plus. Or, as I said, the other way that you can think about this is we have two lines that I can cross through both of these. In either case, we do get negative 9 plus 3. We have different signs, negative 9, positive 3. That means I want to subtract my numbers, giving me 6. Since my larger number is negative, my final answer will be negative. For example D, I want to start by combining my two negatives into a positive. We get negative 5.2 plus 11.4. Even with decimals, the rules are still the same. I want to subtract the numbers. We get 6.2. And I want to keep the sign of the larger one, which was the 11.4. Since it was positive, my answer will be positive. That brings us to problems involving fractions. So when we talk about fractions, we do want to consider that we need to not only remember our rules about the signs, we also need to remember our rules for fractions. When we talk about subtracting fractions or combining fractions using addition and subtraction, remember that we need an LCD. So for example E, my LCD is 12. Now you want to be very careful when you do this when we start having positives and negatives running all over the place, especially the negatives. Make sure that you don't drop any. So I want to start by rewriting each fraction with an LCD of 12. The first fraction I need to multiply by 3. So we get negative 9 over 12. I'm going to put the negative in the numerator just so it doesn't get lost. For the 2/3, in order to get to a denominator of 12, I want to multiply by 4 to the top and the bottom. We get minus 8 over 9. Now from here, 8 over 12. From here, we want to go ahead and combine. So I want to know, do I have same signs or different signs? Here we have same signs. I have negative 9. I also have negative 8. If you struggle with this, one thing that you can do is we can put our two dashes. I'm going to put 1 through my minus sign, and I'm going to put the other one next to the 8. Or change your subtraction to add the opposite. Now we have negative 9 and negative 8. These are same signs, and so I can go ahead and combine them. Since they are same, we are going to get negative 17 over, keep the denominator, 12. We cannot reduce the fraction, and so we are done. Let's look at example F now. Example F, we have 5/6 minus 8/9. My LCD is going to be 18. There's other ones that you can use, but 18 will be the smallest. Remember that we just want a number that is divisible by 6 and by 9. So now let's rewrite each fraction with an LCD of 18. To get from 6 to 18, I need to multiply by 3. To get from 9 to 18, I need to multiply by 2. And remember, whatever you do to the bottom, you have to do to the top. If we multiply this out now, 3 times 5 is 15 over 18 minus 8 times 2 is 16 over 18. So now, do we have same signs or different signs? Well, we have different signs. We have positive 15 over 18. And remember that the minus sign, I want to think of this as being the sign of the second fraction. This is negative 16 over 18. If you want, you can also change this to addition, making it plus negative 16 over 18. From here, we can go ahead and use our rules for combining numbers with different signs. Since our signs are different, we want to subtract. We get 1. Keep the sign of the larger number. It will be negative. Over. Keep the denominator. So our final answer is negative 1 over 18. For example G, the first thing I want to do is take care of the minus and negative. Rewrite this as plus. From there, our LCD, our least common denominator, is 9, since 3 divides into 9. So our first fraction, I want to multiply by 3 to the top and bottom, giving me negative 6 over 9, plus the second fraction can stay the same, 7 over 9. From there, we can go ahead and add the numerators. Since we have different signs, a negative and a positive, we are going to subtract the numbers, giving me 1. It stays positive since my larger number is positive, and then keep the denominator of 9. So there are some problems involving fractions. Let's come down to the last example, example H. Example H, we're going to talk about combining a series of numbers. So the first thing that I want to do is, again, I want to change any of my minus and negatives to pluses. So if I rewrite the problem, I now have 7 plus 7 plus 5 minus 11 plus 6 minus 19. Now, as long as you remember the rule that these minuses are not actually minuses, but negative numbers that are being combined, then we can go ahead and use our rules for adding numbers, our properties. Remember, our properties say that we can add these numbers in any grouping and in any order that we want. Now, if you struggle with the rule of remembering that these minuses are actually negative signs, then you do want to add from left to right. So I'm going to go ahead and do what we did in the previous section, where we can combine our positive numbers together. We have 7, 5, and 6. This combines to give me 18. I can combine my negative numbers. I have negative 11 and negative 19. This will combine to give me negative 30. Again, same signs, add, keep the sign. Now I can go ahead and combine the last two numbers, 18 and negative 30. We have different signs, so I'm going to subtract, giving me 12, keep the sign of the larger number, which was the 30, and so my final answer is negative 12. So those are some examples of adding and subtracting or subtracting numbers with signs. Let's look at an application problem. The hottest temperature ever recorded on Earth was 136 degrees Fahrenheit in Libya in 1922, whereas the lowest temperature ever recorded was negative 129 degrees Fahrenheit at the Vostok Scientific Station in Antarctica in 1983. I want to know what is the difference between the highest and lowest temperature. Though we haven't talked about it yet, difference means subtract. So I want to subtract the two numbers. I want to subtract the highest, 136, minus the lowest, which was negative 129. From here, I want to go ahead and change my minus and negative into a plus sign. So this problem boils down to 136 plus 129. If we add the two numbers together, since they have same signs, we get 265 degrees Fahrenheit. If by chance you get a difference of 7, just think about the fact that where we live, the change in temperature varies more than 7 degrees. It should be a lot more if we are talking about record highs and record lows around the globe. So, note, from here on out, instead of using the terms adding and subtracting, we will refer to the two operations together using the phrase combining. Hopefully this will make a little bit more sense than doing subtractions when it looks like an addition and doing additions when it looks like a subtraction. So let's go ahead and refer to this as combining signed numbers. When will we see this again? Throughout the course, we will be working with signed numbers. We will expand the concept when we talk about simplifying expressions involving variables. We will also expand this concept when we talk about solving a variety of equations, as well as when we talk about polynomials and negative exponents. When we get to factoring, we will need to be able to think backwards in terms of what are going to be the signs if we want to combine to a positive number and combine to a negative number. Try the following problems on your own and bring them to class. Also bring any questions that you have.